Yes, so welcome. My name is Adam SOWA. I'm the CTO at Scythe Studio, and today I'm going to talk a bit about multi-threading in Qt framework. Sorry, it looks like it doesn't. Okay. So my talk is divided into 3 sections. In the first section, I will talk about the past, that is the old and the low-level API that was available in Qt for multi-threading since the beginning. In the second section, I will talk about the present, which is current higher-level API. And in the last section, which I suppose will be the most interesting for experienced Qt developers, I will talk about something that I consider could be the future of how we do complex multi-threading in Qt framework, and this is an abstract and also declarative API. Okay, so let's start with the past, but maybe let's briefly recall why do we need multi-threading at all. So if you want to keep your user interfaces fluid and responsive, you need to offload any heavy tasks to a background thread. And what is a heavy task? It depends on the context, but I think that a good rule of thumb is that if you have something that potentially could take longer than 250 milliseconds, then you should move it to a separate thread, because quarter of a second is already a noticeable delay for a user. Another reason for multi-threading is, of course, if you want to have, if you need good performance, you have a lot of work to do. You need to utilize all cores of your CPU, which also means you need to parallelize your work. And the third most common reason for using multi-threading is that if you have some critical and time-sensitive tasks to do, then normally you should allocate a specific thread for it, and preferably also pin this thread to a single core of your CPU. So the building block of threading in Qt is, of course, QThread class, which represents a thread from an operating system, and it allows you to create such thread and manage it directly. It is older than STD thread, and also it has more features than STD thread. And it is also important to be aware that in Qt framework, every Q object has something which is called thread affinity, and basically it means that every Q object belongs to a specific thread. In order to use QThread directly, you normally subclass it, and when you subclass it, you need to override the run method. And the run method is actually the method that runs on this thread, because the constructor of the thread doesn't run on a separate thread; it runs on the calling thread. Once you have your subclass of QThread, you need to instantiate it. Also in the run methods, you also probably want to emit some signals to either report the results to the rest of the application, or maybe report progress. So later, when you want to use your own thread, then you need to instantiate it. You need to connect your signals, and also what is important, you should connect the finished signal of QThread and delete your custom thread in response to that signal. So the most common way to do it is just to connect it to QObjects delete a later slot. Once you establish the connection, then you can start your thread with the start slot. It is also important to remember that in Qt framework, in order for signals and slots to work across thread boundaries, the receiving thread must be running an event loop, because when you have a signal and slot connection that spans multiple threads, then it is not a direct connection but a Qt connection. Yes, however, that is not the idiomatic way of doing low-level threading in Qt. There is something which is called the worker object pattern, and it is preferred over subclassing QThread directly. So in this pattern, we have a QObject subclass which we move to a particular thread, and the idea behind this pattern is to separate business logic from thread management logic. Also, what is nice about this pattern is that potentially it allows you to quickly move existing single-threaded code to a separate thread. It is not always possible. It, of course, depends on how is your code structured, but if your code doesn't access any other objects in the application, then you can simply move existing class to a background thread using this pattern. The basic example of such pattern is that you subclass QObject, and then you define your slot, which will do the work on the background thread. And as in previous example, probably you want to have some signals, at least to report when your work is finished, maybe also to report results or progress. And here setup is a bit more complex because you, of course, you need to instantiate your worker object, but also you need to instantiate a QThread for it. And then this is the critical part. You need to move your worker object to that thread by calling moveToThread method. Then you need to set up a few signals. So first of all, you need to connect the QThread started signal to the slot in your worker object. Also, you should connect finished signals, your custom finished signal to QThread's quit slot. This is the way to actually stop the thread when it is no longer needed. And also, you should delete your worker object and the thread when the work is done. So you connect the finished signals to delete later slots. And when the connections setup is done, then you can actually start the work by calling start method on the thread. Okay, so when should you use QThread, since this is a low-level API? I think it makes sense to use QThread when you have like some kind of long-running task that you know that will be running for maybe the whole lifetime of the application, or maybe you want to run separate Q event loop. That's also a good reason for having a separate thread. Another reason is that if you want to have direct control when a thread is started or stopped, and since Qt 6.9, we have also a new very good reason for using QThread directly. Nowadays, when we have CPUs, often CPUs have two types of cores. One type is performance cores, and another type is power efficient cores. So if you have a particular code that you want to run either on power efficient cores or maybe on the performance cores, right now in Qt framework there is only one way to control it, and this is QThread's set service level method, where you specify quality of service, and there is a quality of service echo mode to enable this thread to run on power efficient cores. Okay, another way of QThreading in Qt framework is to use a QThread pool. So in this case, you don't have to manage your threads yourself, because QThread pool, as the name suggests, it has a pool of threads, and it manages the threads for you. What you do is you just pass your tasks to QThread pool, and Qt framework creates one thread pool for you. It is accessible by calling global instance method, and you can either pass it a lambda, or if you want your work to be implemented as a class, then you can use subclass QRunnable. First, if you want to have more control, then you can create your own QThreadable instance, and if you do so, then you can also control how many threads should it use by calling the set maximum thread count method. However, it controls the maximum number of threads. It doesn't mean that if you specify 8, for example, that it will always run 8 threads. It will run as many threads as it needs according to the number of tasks that you schedule on this thread pool, but this is the maximum number of threads to be used. And this value for the global thread pool, this value defaults to the number of CPU cores. Okay, so now let's move to the present state of things. So right now, I think it is preferable to use QtConcurrent module, which is much higher level. You also don't need to manage your threads directly, and what is unique about QtConcurrent is that it communicates results or errors using QFuture. QtConcurrent has three families of methods. Run is the simplest method, which just allows you to run some function asynchronously. Then we have a map, which applies a function to each element in a container, and we have filter, which filters elements in a container. And those methods, map and filter, they work in place on the items in the container. There are also 2 other variants of those methods. So there is also mapped and filtered variant, and it differs that it doesn't work on the container in place, but it returns a separate container with your lambdas applied to each element. And there is also mapped reduced and filter reduced, which fold or reduce the container to a single value, and they return a single value. Yeah, so the most basic example of using QtConcurrent is just to pass it a function or a lambda to be executed, and it will return a QFuture class, which is specialized with the return type of your function. Under the hood, QtConcurrent uses QThreadable. So I think the guideline when to use QtConcurrent or QThreadable is very similar actually. So I think this is ideal when you have a lot of short-lived tasks, or you want to run something quickly on a background thread, and you don't want to manage those threads directly, and also maybe you have really a lot of tasks and you want to do it efficient, then you can just add all those tasks to QtConcurrent or QThreadable, and it will manage the number of threads according to available system resources. Okay, now let's talk about QFuture, which is the way of reporting results with QtConcurrent. So basically, it represents some future value and allows you to query the value also and the status of the operation. As a minimal example, if you invoke some method that returns QFuture, like the QtConcurrent run, you get back the future, and you can just call the result method to get the result of this operation. However, you need to be careful, because if the result is not immediately available, this method will block until the result is available. So if you aren't careful, then you can reduce multi-threaded code to single-threaded code, basically, because your thread will, your main thread, you will be waiting on the for the background thread. So much better way to query QFuture for results is to use, for example, signals and slots. So we have QFuture watcher class, which you basically pass a future to it, and then it emits the finished signal when your future is finished. So in the slot connected to this signal, you can access the result of this asynchronous operation. However, there exists another way more functional style without using signals. So QtConcurrent QFeature allows you to add continuations to it. So you basically call the then method, and then you pass a lambda, and this lambda should take as an argument the type that this QFeature is specialized. So basically the return type of your asynchronous operation. And as you can see on this slide, you can actually chain a multiple invocation of it. They don't have to be the same type. Yes, and also what is important here is normally those continuations execute on a background thread. So the continuations are executed on the same thread as the original asynchronous operation was executing on. However, if the future is already finished by the time you call the then method, then your continuation will be executed immediately, which means will be executed on the calling thread. So you need to be careful because yes, you don't always know which thread will execute your continuation. Actually, unfortunately, there are many pitfalls to QFeature. If you go into details, there are many corner cases. I don't have time in this talk to describe all of it, so I will just mention some major ones. So one pitfall is that it is not always safe to call the result method. Basically, it is only safe to call the result method if you test that is valid method returns true. And examples of when this method will cause trouble is, for example, if a future is cancelled, or a future returned an error, or you have a future that hasn't started yet. Then this method will either block or crash. Yes, so QFeature has a few methods to query its status, actually quite a lot. I think that now I will just mention the most important one, which I also highlighted here. I mentioned this is valid method already. Another important one is this is result ready at. So basically it tells you if a result is already available. If it returns true, then you can call the result method, and you are guaranteed that it will not block. Also, the is finished method is important to know that this asynchronous task is done executing, and there will be no future updates to the status of this QFeature. And also, is cancelled method allows you to query if this if this operation was executed at all. Maybe it was cancelled because of error, or you explicitly called the cancel method on a QFeature. The way to report errors here is a bit unusual, because normally in Qt framework APIs don't use exceptions, but here in the case of QFeature it does use exception. So if you want to communicate your custom errors, then you need to subclass QException class and implement at least those two methods, which is rise and clone. The way to handle errors, there are actually at least two ways to handle errors. One is to use on-failed continuation style, and it is very similar to using try and catch block in C++. And by that I mean that you should structure this code. So first you call on failed with the most specific exception types, and later with the more generic type, because if you do the other way around, the generic callback will be matched, and not the one with your specific exception class. There is also a way to handle unexpected exception types, and you can do it by using, like, for example, also a try catch block, and try to catch Q unhandled exception. Yeah, I already mentioned that quite a few pitfalls with QFeature. One of them is that you can have silent errors, because exceptions are not propagated unless you call one of the 4 methods on a QFuture. So basically, unless you query for a result, an exception will be never propagated. So you will never know that something bad happened. Okay, now let's talk about the other side. So if you implement your own asynchronous code and you actually want to communicate the result back to the caller, you use QPromise class for it. So first you need to create an instance of it, and then you need to get the future that you will return from your method to the caller. You get instance of the future by calling the future method of your promise, and then you start your asynchronous operation probably on a separate thread. And as soon as this operation is started, you should call start a method on the promise. It will also change the status of the QFuture to started. When you have one or more results, you communicate the result back by calling add result, because QFuture can actually transfer more than a single value. And when you are done with your operation, you should call a finish method on QPromise. Okay, let's now talk about a possible future for multithreading in Qt framework. So there is a library called task tree, and actually this library was developed as part of Qt Creator, and it is used heavily inside Qt Creator. It's a generic library for asynchronous tasks, and what makes it unique is that it allows you to declare your tasks in declarative way. Here I can only briefly mention this library on the following slides, but if you are interested in it, then I encourage you to visit this wiki page, which talks more about this library. And if you agree with me that this would be a valuable addition to Qt framework, then please upvote or comment this bug report. I created a bug report suggesting that the task tree library should be added to Qt framework. Okay, so as I said, this is kind of declarative way of describing asynchronous work, and the basic idea is that first you describe all the work to do, and this is done by creating so-called recipe, which describes all the tasks or order of the task, various details of it, how to set up each task, or how to communicate data between those tasks, and what to do in case of errors. And then you pass this recipe to the task tree, which is the executor, and it will instantiate all the objects as specified in the recipe, and then it will make sure those are executed as you specified, and then it can also possibly skip some of the tasks if there are any errors, and you specified that you don't want to ignore errors, for example. So this is a very simple example how such code looks in practice. So the recipe is actually represented by a group class. As the first argument to the constructor, you specify execution mode, and there are 2 execution modes. One is sequential and another one is parallel. So if you specify sequential, then all the tasks will be executed sequentially. The second parameter, in this case stop on error, is optional workflow policy. Stopping on error is the default behavior, but you can also specify that you want to continue on error, or that you want to stop on success. There are quite a few possible values here. And later we specify the first task. In this example, it's called network query task. After that, we specify the second task, which actually is a group, because task tree supports nested task, and you can actually have another group and you can specify different policies for each group. So in this example, we have a child group, and this group uses parallel execution mode. So it means that those two concurrent call tasks will execute in parallel. So when this recipe is executed by task tree, first it will execute network query task, and after this task finishes successfully, it will enter this second group and will execute those two tasks concurrently. Task tree is actually quite complex and quite expressive. It overloads C++ operators, so you can really describe what should happen to your tasks in a very expressive way. So in this example, we specify that we have task 1 and 2, and we require both tasks to succeed, but task 3 and task 4 we join by the OR operator, which means that either of the task needs to succeed for the whole recipe to be considered a success. And in the case of the last task, we use negation, which means that we expect this task to fail. So if the last task succeeds, that would be actually considered an error for the whole recipe. You can also have more complex conditional logic. So you can specify that if some task succeeds, then you want to execute another one, or you can also have like else if conditions or else conditions. So task tree is actually quite complex and quite expressive, and I think it's really suited if you have very complex logic for your asynchronous tasks. So thank you very much.